In this video we will be exploring the fundamental concept of voltage dividers. To help understand voltage divider, we can imagine voltage as one big pizza. You and your friend, the two resistors, agree to split the pizza but not evenly. Whoever gets more pizza will depend on your appetite, resistance. The bigger the appetite, the bigger the share of the total pizza, voltage. The pizza is the voltage into the circuit, and you and your friend are two series connected resistors R1, R2 of varying resistance. If your appetite is bigger resistance, you will get a bigger share of the pizza, voltage, than R2. Note, the voltage taken up by the resistors will always add up to the input voltage. Putting this in a more formal definition, we have a voltage divider is the sharing of the input voltage among resistors that are connected in series. In a series circuit, the current is the same across every point as there is only a single path for the current to flow. The supply voltage is then divided up across these resistors in proportion to their resistance values to stay consistent with Ohm's law, V equals IR. This means, the larger the resistance, the larger the share of total voltage it gets. Looking at an example of this, we have to find the voltage across R1. Firstly, we find the total resistance of the circuit by adding the two series resistors values together to get a total resistance of 25 ohms. Then we find the current flowing through the circuit using Ohm's law to find the current to be 0.48 A. Now to find the voltage across the resistor, we use Ohm's law again with our current that we found and the resistance of the resistor, giving a voltage of 7.2 V. There is an easier way to find the voltage drop across resistors in a series circuit using the voltage divider equation. The general equation is the voltage across the resistor is equal to the total voltage of the circuit times the resistance of the resistor divided by the total resistance of the circuit. So, voltage across R1 is equal to E times R1 over R1 plus R2. To verify this equation works, we can find the voltage across R1 by subbing in our values for the circuit into the equation. This gives a voltage of 7.2 volts, which matches our previous answer. To verify either of these voltages are correct, we can find the voltage drop across R2 and see if the voltage drop across R1 and R2 is equal to supply voltage. In summary, supply voltage is shared amongst the resistors in a series circuit. The amount of voltage taken by a resistor is proportional to the resistance of the resistor. V equals IR. The larger the resistance, the larger the share of the total voltage it gets. The sum of the voltage drops across each resistor is equal to the supply voltage.